Good day everyone, welcome back once again to my channel, The Great Check, and once again, this is Jerry, and welcome to my Sky Classroom. I just want to shout out all the students of Santa Fe National High School, particularly for all the students of senior high, specifically the grade 11 classes. So I just want to shout out specifically in a special way my advisory class, grade 11 Shakespeare. And how are you, class? And hopefully you're just fine today. And how's your Holy Week vacation, including those days that we had the typhoon. And of course, I just want to clarify, shout out also the students that belong to the grade 11 EBM Mask. How are you, class? Welcome to our Sky Classroom. And of course, the grade 11 Roses, Humes, grade 11 Humes, Roses students. How are you, class? Welcome to our Sky Classroom. And I just want to shout out also the grade 11 Homer. How are you, class? Good day, and hopefully that you're just fine today. And I just want to shout out also the grade 11 Humes, Milton students. Good day, class, and welcome to our Sky Classroom. And also the grade 11 Humes Mujares. Kumusta, class? How are you today? Hopefully that you're just fine as you're watching this video, our first video in our Sky Classroom. And I think I already have mentioned all our students that belong to my subject, physical science. So welcome to our Sky Classroom. I also want to shout out all the teachers of Santa Fe National High School, all the junior high school teachers, and of course our senior high school teachers. How are you, my fellow workers? Good day and welcome to my channel, Great Check. Okay, so all those who are watching this time, welcome. And once again, this is Jerry, and in this video, this is my Sky or our Sky Classroom for my physical science subject. And welcome to this module, to this lesson that we have in this video today. So we are in the module 1, quarter 3 of this subject, physical science, and we're gonna be talking about the formation of heavier elements during the stellar or star formation and evolution. So what we will learn today is you are expected, class, to define stellar nucleosynthesis. Okay, try to put that in your mind. I am going to, or I will expect that you will learn how to define stellar nucleosynthesis. So what is stellar nucleosynthesis, class? Do you have any idea? The word stellar, constellation. When the word constellation comes to your mind, if you hear the word constellation, which is, there is something from the word stellar inside that word constellation. So it's all about what? Stars, right? So stellar, constellation, stellar, nucleosynthesis. So it's all about the process of the star. And the second one is you're expected to give evidence for and describe the formation of heavier elements during star formation and evolution. Okay, so before we continue with our discussion this time, so I just want you to answer this part here as what you can see in the video. So we have 5 questions in there. It's not a question. Anyway, of course, the definition of term. So try to identify. This is an identification part. Okay, you have 5 questions here that you will identify this definition. Okay, then just write it in your scratch paper. Okay, so just post this so that you could have the time to answer first, then we'll continue in the next part. I'll just give you 5 minutes for this, but in my in this video, just post and then answer. Then if you want to have clarification, you can also replay the part of this video. Okay, so I'll just give you 5 minutes to have this, then we'll continue after that. Alright, so we'll continue. We're gonna be indulging to the lesson now. So stellar evolution, we have the word term stellar evolution. It deals with the various events of star's life. So a life has a beginning and it has an end. So it's not the same with how God created everything. Death is not part of His creation. But when we talk about life in our finite minds, it has the beginning and it has an end. So stars also have the beginning and also have the end, or of course the end. So the star's life, from dense molecular cloud to the time when the star becomes exhausted through its nuclear fuel, and of course there is a chemical process for that, how it is formed, or the heavy elements are formed within the stars, and it is called stellar nucleosynthesis. It's still a slight definition of the word stellar nucleosynthesis. So this process requires high amount of temperature. We need to have the temperature, we need to have the pressure, we need to have the energy, so that the fusion will take place to create heavy elements. Okay, so before we continue that one class, I just want to have this picture analysis. So I just want to ask a question. Which of these two pictures is most likely similar in the formation of heavy elements? So you already have the slight idea. You already have the slight idea of what heavy elements are, or the formation of heavy elements, as what we have just mentioned a while ago. So we have the picture A and we also have the picture B. Okay? Alright, so the picture A, it is or he is a wizard. Okay, and picture B, there are three witches who are working together. So picture A is a wizard, and the wizard wanted to do something or to wish to happen. So just in a snap or blinking of an eye, when he wanted to make something, then it went out, it existed. While the other part, or the other picture B, the witchcraft or the witches were working, or they are working together to make a fusion class. So which of these pictures similar to forming the heavy elements? Of course, it is most likely similar to the formation of heavy elements if we consider picture B. So there's a process that it becomes something, as these witches were working together to make particular potion. Okay, so we will indulge now. We will continue. We will clarify this all. So how do stars are formed is what we are going to learn today. And how do heavy elements are formed also. So there is a theory which is called Big Bang theory. So the Big Bang is a theory that deals with how things or universe started. So the theory talks about, when we talk about theory, so it has no facts yet. It's not it is not yet confirmed, so it's still a theory, or an idea how things are done or formed. So they said that from lighter elements, these lighter elements are formed during the Big Bang nucleosynthesis until it processes until it becomes something. And the same with the heavier elements also, that they have that idea that heavy elements are formed through stellar nucleosynthesis. So what is stellar nucleosynthesis? We do have the idea that it is a chemical process of forming heavy elements within the stars, as the word stellar is about stars. So stellar nucleosynthesis is a formation of heavy elements within the stars. So how stars are formed, or the heavy elements are formed within the stars, it is called the stellar nucleosynthesis. So as the stars are evolving, there is a greater possibility of formation, and as the stars are evolving, there is a greater possibility of formation and changes of elements. So there is an evolving of something. When the stars evolved, then from nothing to something. So we're gonna be, of course, we have to make it chip by chip to explain everything. So we have this term stellar evolution. So it evolves as time goes by. Though there's an evolution, there's a changes. There are changes happening. There are changes taking place as time goes by. So stellar evolution, we have this. What is stellar evolution? It is an event of changes of a star during its lifetime from evolutionary phase of protostar until its stellar death. So from protostar, the stars are evolving from evolutionary phase of protostar until its death, and that death is called, the death of a star is called supernova. So this theory, which is the theory of collapse under gravity, is considered as the major theory of star formation. So we have that theory of collapse under the gravity. So everything is working, everything is done under the gravity, or considered as the major theory of star formation. So the stars are formed by the gravitational collapse of dense molecular cloud. So as the molecular cloud collapses, the fragments from different regions are grouped to form stellar core. So there's a stellar core. So when you talk about stellar, the star has a core. So that core is called protostar. So from the molecular cloud, when the molecular cloud collapses, so there's a cloud glass of molecules. Then if it collapses, then the fragments of different regions of that molecular cloud are grouped together to form stellar core. So grouped together when the molecular clouds collapse, and then the fragments are grouped together and it formed into something. It is formed into stellar core. It becomes the core of the star. It becomes from a small particle glass, and it formed into that stellar core, which is called protostar. So as the protostar's temperature increases, the nuclear reaction starts up to convert hydrogen into helium. So these elements, which are gases, are formed. The temperature of protostars, when it increases, the nuclear reaction starts to convert from hydrogen to helium in its core. Then the star is formed into the main sequence. So it is called the main sequence when it's the star is formed in its core through the conversion of hydrogen into helium. So as the star continues converting hydrogen into helium, then it becomes the main sequence. It is called the main sequence, that something which is formed, the fragments of the molecular clouds. And that, of course, what I said, it is the protostar, the fragments that are grouped to form a stellar core. So core, something, when we talk about core, when we have that egg, if we have that egg, the core of the egg is the yellow, or the yellow yolk. So that's the core. Our Earth has a core also, the inner core and the outer core. So eventually, class, when the main sequence star fuses so much of its hydrogen into helium, then the fusion will stop. So the pressure in the core is reduced. So there's a pressure inside, but inside that core, the pressure is reduced when there is so much fusion of hydrogen into helium. So meanwhile, the star's core cools, so it cools down after the fusion stops. When the fusion stops, then the star's core will cool down. Then it begins to contract again. So there's a contraction again. There's something that there's a power that will unleash again into that core of that star when it cools down. So in this case, the contraction increases the pressure and the temperature of the star's core. So there's a contraction, there's a the contraction, there's a contraction again. Then the contraction will increase the temperature and the pressure of the star's core. So there's something in that core that will burst out again. And in that core, the helium will be converted to carbon. So from hydrogen, then the contraction becomes too much, and the hydrogen, the fusion, if the fusion is too much of its hydrogen and helium, then it stops. But meanwhile, when the star's core cools down, then there is a contraction again, and that contraction will increase the pressure and the temperature of that star's core. And in that core, the helium will be converted to carbon gas. So from the hydrogen element to helium element, then it stops, then there's a contraction, and that contraction will increase the temperature and the pressure, and then inside the core, the helium element will be converted to carbon. While in the shell, class, so there's a shell in there. So while it's in the shell, the helium will become a carbon, and then the hydrogen is converted into helium, making the star red giant. So the star will become a red giant. So when we see a giant, when the coal or the ember, when we have that charcoal, when we heat the charcoal, then the charcoal will become red. There's something that will come out later, that red charcoal. So that is what is happening also in the star. The hydrogen is converted into helium, making the star giant. And the stellar evolution produces elements through iron. So it becomes the elements while the evolution continues, the stellar evolution continues, then it produces elements through iron. So the star's outer materials are blown off into the space, and the remainder of the star becomes a white dwarf. That means, class, when it is exhausted, it becomes a red giant, the star becomes a red giant, then it bursts out, boom! then the outer materials of the stars that are blown up into space, then that's something that remains after the explosion. It is called a white dwarf. The star's cores can no longer make energy to resist from gravity. So it has no energy anymore. It has no energy. When you are exhausted, when you work so much, then your energy is gone. Then there's no more energy, and that is what will happen also in the star. It cannot resist anymore from gravity. So the star now will explode and release a large amount of energy, and this explosion is called or referred to as the supernova. Boom! Then the fragments, the materials, the outer materials of the stars, then there's something that will remain inside that star, in that star, and that is called a white dwarf. But the explosion from from when it becomes a red giant, when the star becomes a red giant, and then it explodes, then that explosion is called supernova. So if you can see here the process, class, if you can see what you can see on the screen, you can see in there that this is the shell fusion. So here, class, this is the process. The picture here that you can see on the screen is the process of the evolution or stellar evolution, class. So from the non-burning hydrogen, then it becomes a hydrogen fusion, and then when the hydrogen is converted into helium, so there's a fusion of helium, then the helium becomes a carbon fusion, then goes into oxygen fusion, then neon fusion, magnesium fusion, silicon fusion, and the iron ash. Okay, so this is the whole picture of the stellar or shells fusion, class, of the life of a star. So the shell fusion is the process of formation of new elements in its layers or regions. So from this case, the carbon fusion will form oxygen, then carbon fusion will form oxygen, and oxygen into neon, and neon into magnesium fusion, and magnesium fusion into silicon fusion until it becomes an iron ash. So when the new elements are produced, new layers are added up to the size of the star until it becomes a multiple shell red giant. So that is what is happening in the life of the stars through its shells fusion. So shell fusion, once again, is the process of formation of new elements in its layer or region. So this is the process, class. This is called shell fusion, from non-burning hydrogen to a hydrogen fusion until it becomes an iron ash. Okay, so next, or one of the significant evidences to support the formation of heavier elements during stellar evolution is the interstellar medium. So these are the evidences, or that evidences that support through this formation of these heavy elements during stellar evolution. So the stellar or the interstellar medium is all the collection of interstellar matter. What is interstellar matter? Interstellar matter refers to the materials between the stars. So those materials between the stars are called stellar or interstellar matter. So about 99% of these materials are in the form of gases. So when we see a star, So 99% of it, of that star, of the materials of that star is gases. So it is composed of gases, class. The most abundant gases of that materials are helium and hydrogen. So if you can see in there, the core, class. So most of the materials inside the star, or the star is composed of, is gases, and more of it, abundant gases of that gaseous forms, or that gases inside the star, is helium and hydrogen. And the remaining one, which is only 1%, is the form of solids, which are frozen particles. So that small solid inside the star, which are frozen particles, so icy particles. So it though it's solid, but still it's an icy, or the solid part of that star, or the materials of the star, is frozen particles, which is called interstellar grains. So grains. So if you see the sand, if you put the sand in there on your palm, so sand, you can just take something, a small amount of sand from the beach, and put it in your hand. So they try to imagine that one, that there are solids inside that star, and it's frozen particles, and it's called interstellar grains. So the interstellar grains are made up of rock-like materials, rock-like materials. So that is the star composed of. So another evidence to corroborate the formation of heavy elements is infrared radiation. So infrared radiation. The word infrared, to understand that one, is our remote control. So we have the remote control. So most of our old remote controls are infrared. So you can control your television through that remote control. And infrared radiation, that means the remote control can control the television through infrared radiation. So if you try to see how infrared works, so just if you can see on your, let's say this is your remote control, you can see something here. It's a light like a bulb. So that's the way how the remote control communicates to the television. So if you cover your remote control with your palm, the part wherein you can find the like a bulb, so if you control your television, you can't control it anymore. It's because it is controlled through infrared. So infrared radiation is something like that. It is a form of energy detected in the process of star formation. Astronomers are using, or they use infrared radiation to estimate the pressure, temperature, and energy in the evolutionary phase of star formation. So they use infrared radiation. That's how they study to estimate the pressure of during star formation. Okay, that's all for this time, class. So hopefully that you have learned something. But before that, so that I may know if you have learned what we have discussed, or what we are discussing this time, or what I have discussed, what we have learned, what we have studied just a while ago, I just want you to have this short and quick assessment. It's not a formal assessment, but I just want to know how far you have learned through this topic. Okay, so I'll just give you just 5 minutes to answer this one again. So we have this matching type. Okay, we have the column A, which is we have 5 terms in there, and column B is the definition. So just pause this one, pause it so that you could answer it through your. I don't have to read this one, just answer it. Okay, so I'll just give you the time starts for 5 minutes to answer this question now. So right, so time is up, and we'll see if you have answered correctly, class. So interstellar grain. What is interstellar grain, class? Huh? What about multiple shell red giant? Number 3, interstellar medium. Number 4, infrared radiation. And number 5 is shell fusion. Okay, we'll see if you have answered it correctly. Okay, so we'll answer it. So what is your answer? Okay, here is the answer. And try to check if your answers are correct. Okay, well, number 1, letter C, interstellar grains. What is it? It is, or these are frozen materials. Number 2, multiple shell red giant. What is it? Letter E, layers are added up in the regions of the star. Then number 3, interstellar medium. What is interstellar medium? These are all the interstellar materials found in the stars. Interstellar materials found in the stars, class. And number 4, infrared radiation. What is it? Letter B, the energy found in the star formation. And number 5, shell fusion. Letter D, a process of formation of new elements in the star. Okay, so how many answers which are correct, class? Who got 5? What about 4? 3? 2? 1? What about 0? Okay, hopefully that no one got 0. Okay, so next, what's more? Define the following terms, class. Use a separate sheet of paper for your answer. Okay, try to answer this one. Just pause this, then you can have your answer inside it. Okay, or within that 5 minutes. Okay, just pause, class, for 5 minutes. Okay, done. So we'll continue. So what is dwarf or white dwarf? What about protostar? What about stellar nucleosynthesis? What about multiple shell red giant? And what about interstellar grain, class? So the answer is here. White dwarf, the remainder of the star. Can you still remember? Remainder of the star, after the explosion. And then there's something that remains, and that is called white dwarf. Then what is protostar? Protostar is or are fragments from different regions which are grouped to form stellar core. So that's protostar. The first. So when the molecular cloud collapses, then the particles will be grouped, and that is called protostar. Okay, the fragments. Okay, next, stellar nucleosynthesis. It is the formation of heavy elements within the stars. Okay, number 4, what is multiple shell red giant? These are new layers that are added up to the size of the stars. Okay, and number 5, interstellar grain. So these are frozen particles of the materials between the stars. Okay, who got 5? What about 4? 3, 2, and 1. Time is up. Okay, no one got 0, hopefully. So next is we will review what you have learned in this lesson. Okay, so the first one that you have learned, if you still remember or if you have learned, okay, number one is we talk about stellar nucleosynthesis, and it is a formation of heavy elements within the stars. The second one is the meteor theory of the star formation, which is it is the theory of collapse under gravity. The third, the protostar. What is a protostar? It is formed when fragments of molecular clouds are grouped. Okay, and then number four term that you have learned. It is the interstellar matter. What is interstellar matter? It refers to the materials between the stars. And of course, the fifth one, the supernova. Supernova. You know the junk food supernova. It is really good. It tastes so good, but it's not good for your health. So the explosion, the violent explosion of the stars, is called supernova. And the sixth one, the interstellar medium. Interstellar medium. What is interstellar medium? It is all the collection of interstellar matter in the star. And the last one, the infrared radiation. It is a form of energy detected in the process of star formation. So hopefully, class, that these 7 terms that we have learned is or it will remain in your mind, class, through this lesson that we have in this video. So what I can do, so can you still label this one, class? Can you label the 5 remaining terms during the star life, or the life of the star, class, or the stellar nucleosynthesis? Okay, stellar nucleosynthesis. Okay, so can you still label it? Try to label it, class. Okay, just do it in 5 minutes. Still 5 minutes, class. Probably you can make it in 1 minute. Okay, and then just pause it, class. Pause it. Okay, then continue. The answer is here. From non-burning hydrogen to hydrogen fusion, helium fusion, then carbon fusion, then oxygen fusion, neon fusion, magnesium fusion, silicon fusion, and the last one is the iron ash. Okay, so class, alright, so we'll have a short assessment this time, and it's your favorite test type. It's a multiple choice. So we have 10 questions here, and each question has 4 options, 4 choices that you can choose from. And you can just pause the screen and continue with the next slide for you to have the another 5 set of questions. So this time you can just write your answer on a separate sheet of paper, and you can just screenshot or take picture of it from your paper wherein you have your answer or answers, and then you can just send it to my Facebook or Messenger. Okay, so I'll just give you 10 minutes, and then after that we'll end our discussion. Time starts now. And time is up. So before you take photos of your answer and send it to my messenger. Okay, so for the last part of this video, this activity, this lesson, I will give you the additional activities, and what you'll do is draw and arrange the the chronological sequence of stellar evolution. You can write it on a separate sheet of paper, and then you can also, of course, take photos of it after you have done the answering, and then send it to my messenger as your personal message to me, so they could also check it, and then I will give you the points. So class, if you haven't subscribed yet, please subscribe and click also your notification bell so that you'll be notified if we have new lessons in the series or in our subject physical science. So of course, like the video and share it to your friends. If you think that they haven't watched this yet, or they haven't had this lesson yet, so you can tell them also by sharing this video to them. So thanks for watching, guys. So have a nice day and see you in the next video. May the Lord Jesus bless us all. Bye bye.